Hi to everyone. This is Sindhuja, Department of Mathematics. Let us have a discussion about the unit of functions of several variable. Here we are going to see how the maxima and minima plays a role in this functions of several variable. So before going to the problem of maxima and minima, let us see what is the necessary and sufficient condition in maxima and minima. The first necessary condition is it should be derivative f, it should be differentiated, that is f dash of c is equal to 0, and second is f dash of c does not exist, the necessary condition for extreme value in a closed interval. So when the sufficient condition for maxima and minima is f dash of x is less than 0, that is concave down as shown in this picture, and f dash of x is greater than 0, that is concave up as in the figure, that is in the graph. If the point a comma b a critical point of f of x comma y, then the partial derivatives are 0, that is both the partial differentiation with respect to x, that is fx of a comma b, and partial differentiation with respect to y, fy of a comma b, are equal to 0, indicating a potential maximum and minimum. The partial derivative does not exist, then at least one of fx of a comma b or fy of a comma b does not exist, suggesting a sharp edge or discontinuity. So now let us determine a maxima or minimum here in calculating the Hessian matrix. Compute the second order partial derivatives and arrange them in a matrix. Compute discriminant, that is calculate the discriminant using the elements of the Hessian matrix. Classify the critical point. Use the discriminant to determine if the critical point is maximum, minimum or saddle point. So let us see what is the condition of critical points. So in the condition we are going to see the maximum, minimum, saddle point and inconclusive with an condition of capital D which is greater than 0 and fxx is greater than 0, then it is named as an local minimum. If the D is greater than 0 and fxx is less than 0, then the condition is local maximum. The saddle point is if D is less than 0, then no need to check about fxx, the second order derivative, and inconclusive is when the d is equal to 0. So what is d? D is nothing else but ac minus b square, that is coefficient of x square, and constant minus the coefficient of x, the whole square. So visualizing the critical points in multivariable calculus, so which is picturized as an minimum point, maximum point and saddle point, where the lowest point in a region is an minimum point and the highest point in a region is an maximum point. The point that is neither maximum or nor minimum is an saddle point, where we named as an critical points. So let us see the example with a function of f of x comma y equal to x square plus y square. So when you are differentiating here, we get fx is equal to 2x and fy equal to 2y. So it satisfies the necessary condition which is differentiable. So when we are going for second order derivative fxx, we get it as 2 and fyy as 2 and fxy as 0, that is when you are differentiating partially with respect to x then with respect to y, and we get d, that is ac minus b square equal to 4, which is greater than 0. So when the d value is greater than 0, we have to check fxx also. So here fxx is 2, which is greater than 0. So we can conclude the local minimum point at the point 0 comma 0 and local maximum. So for the local maximum, the d should be greater than 0 and fxx should be less than 0. So here we are taken the function of f of x is x comma y equal to minus x square minus y square. We get capital D as 4, which is greater than 0, and fxx as less than 0. So it is local maximum. So when the case is saddle, that is when d is less than 0, for that the function may be in the form of x square minus y square. So here we get d as minus 4 when you are differentiating, so that we can conclude this one as an saddle point. So in which case we used to say it as an inconclusive case. So that is for the function when you are differentiating and simplifying, we get d as 0, then we can say it as an inconclusive. So as a summarizing, let us see how this maxima and minima plays an role with a necessary and sufficient condition in our day-to-day life. So imagine designing a reflector dish or a drainage bowl. Which type of critical point would you prefer for the center of service and why? So when you are designing the shape of robotic gripper's fingertip that must securely hold small spherical objects like bearings or marbles without letting them slip at the point of contact with the object, what type of critical object maxima minima or saddle should the fingertips surface have and why? Think in terms of stability, surface curvature, and how forces act on the object. So, with this, let us conclude this session. Thank you.